Okay, not time to give up yet. We're only just getting going. Come on, wake up. So, over here, we're going to do Pythagoras theorem again. So we're going to continue on with some Pythagoras theorem questions. We're C, A, B. I always just keep remembering to use this the same shape, i.e. always with the C as the biggest letter, then as the hypotenuse. So, let's have a look at this question. We draw the triangle, put the 10, the 6, the x, they're all in centimetres. Now this actually has the x as a shorter side, this question, C, A, B. However, I am going to keep using the same rule. So 10 squared equals 6 squared plus x squared. Now I hope everyone understands this is the one I want. So I've got my 100, 6 squared of course is 36 plus x squared. So rather than memorize a different formula, I'm just going to use the same formula, but after I've done the squares, I'm going to move that number out of here. So that's 100, take 36. When I move the 36 across, it becomes negative. Or I take 36 from both sides, depending on whichever way you like to think about the question. Anyway, this leaves 64. And this is how this works out. This is probably one of those numbers we would expect you to remember. 8 squared is 64. 9 squared is 81. 6 squared is 36. A couple of these happening in the background at all times. Get that off the page. Let's have a look at part B very quickly. I've got my diagram. X, 7, 8. I must remember to put the right angle in, just like I did here. I didn't forget, honest, did not forget. C, A, B. C is always the long side for me. C squared equals A squared plus B squared. So 8 squared equals 7 squared plus x squared. 8 squared is 64, 7 squared is 49. Here is x squared. I need this to depart the building. I need it to move across to the other side. Join the other barbecue. When I move it across, it becomes negative. 64 take 49 means maybe 15, I think. And for this question, leaving the square root form, it wanted my answer to look like this. Centimetres. Boom. Okay, keep working on that organisation. I need to find a pen that works. Let's have a look at the next question. Length unanswered, and we have the 3 significant figures again. Gonna need the calculator. All right, so all these questions, gonna be using this rule. Mainly because the chapter is called Pythagoras, so every question in the chapter is going to use Pythagoras. Let's have a look at this question here. We'll probably only do one of these before we move on to the next. You'll probably do a couple of these in class. Jump along, we label. The hypotenuse in my idea is called C. It doesn't really matter which one is A and which one is B. It matters that I'll put the lid back on the text. So C squared equals A squared plus B squared. That's all I've got to remember here. Of course, I will have a formula sheet for this test, for this next topic. So what's the C? It is 13. The A is 11. Now, 169, 121, and I hope everyone's clear that we want to subtract this part to get the x's by themselves. Rather special, the x's need to be by themselves. Well, 1 from 9 leaves 8. 2 from 6 leaves 4. And this time we're going to be here. I'm always very keen for students to show when this changes from x to x squared into x. Always like to show that very clearly. Anyway, square root of 48. Delete. Hope we can see this here. All right. Shift square root 48 as a decimal. This is the FD button here. 6.928. So I will write that out. 6.9282003. Three significant figures means 1, 2, 3. Do I round up or down on the 8? I think I round up. Not sure about that approximate. It's supposed to be an equals that's slightly bent, so let's go. Still not happy with that. Rest of it was great though. Awesome. Okay, looking at F. What I need is that here, what we're simply going to do is try and ask the same thing with a few little tricks. If this is an X, that line means this is the same, and this is the X. Oh, it looks a bit mysterious. Doesn't look like I've got enough numbers on here, but I'm going to follow the formula as before. CAB. C squared equals A squared plus B squared. In this case, this is 12.7. I'm going to do 12.7 in my head very easily. But this, the A is X squared. Oh, and the B is X squared. Right, a little bit of algebra. Well, how many of these have I got? I've got 2 of them. This one plus this one. So I've got 2 of these X squareds. And I'm past the awkward step. 12.7 squared. So what this number is, now we've got to get, well, what's the opposite of timesing by 2? We need to divide by 2. So first of all, before we get too much further, who knows what 12.7 squared is? 12.7 squared. Really do hope that's showing up. Perhaps if I put it directly under. Is that better? Is it better at a good height? Not sure. Maybe if I put the pen near it. Anyway, 161.29 equals X squared. Now on this here, to get rid of the 2, I'm going to divide by 2. Now I'm going to show that there. So I've divided by 2. That's how I've got rid of the 2 in front of the X squared. All right? So divide by 2. So let's divide this number by 2. 80.645 equals X squared. So X is the square root of this number. Clearly showing where I went from squared down to X. To get the shortcut on the calculator, we use the answer from before. So this answer button here, shift answer. So I don't have to keep putting these numbers in. 8.9803 significant figures. I'm just going to stop there. Units are centimeters. Boom.